How do you representing a circle in coordinate geometry? Have you ever wondered how to representing a circle using coordinates? It might seem tricky at first, but once you break it down, it becomes quite straightforward. Let's take a closer look at how this works in coordinate geometry. In coordinate geometry, a circle is represented by an equation that connects the coordinates of any point on the circle to its center and radius. The most common way to express this is through the standard form equation of a circle. The equation looks like this. X minus h squared plus y minus k squared equals r squared. In this equation, the letters h and k representing the coordinates of the center of the circle. The letter r stands for the radius of the circle. The letters x and y representing any point on the circle itself. This equation is based on the definition of a circle, which is the set of all points that are at a fixed distance, the radius from a fixed point, the center. By using the Pythagorean theorem, we can show that the distance between any point x, y on the circle and the center, h, k, is always equal to r, leading us to the equation we just mentioned. If the circle is centered at the origin, which is the point 0, 0, the equation simplifies to x squared plus y squared equals r squared. This form is easier to work with when the center is at the origin. There is also a general form of the circle's equation, which is a quadratic equation in x and y. It looks like this. Squared plus y squared plus 2 times g times x plus 2 times f times y plus c equals 0. In this general form, the center of the circle can be found at the point -g and -f to find the radius. You can use the formula r equals the square root of g squared plus f squared minus c. This form is useful when you have the equation in expanded form and want to find the center and radius by completing the square or comparing it with the standard form. You can also express the circle as to functions that representing the upper and lower semicircles. The equations for these semicircles are y equals k plus or minus the square root of r squared minus x minus h squared. This breaks the circle into two parts, which can be helpful for graphing or analyzing the circle piece by piece. Practical applications of representing circles in coordinate geometry include determining if a point lies inside, outside, or on the circle by plugging its coordinates into the equation. You can also find points of intersection between circles and lines or other curves. This is especially useful when solving real-world problems that involve circular shapes, such as designing round objects or analyzing circular motion. Understanding these forms helps simplify the concept of circles into manageable algebraic expressions, making it easier to work with shapes, angles, and distances in geometry.